Okay, we're going to start the second part of the math review. So I'm not going to go through all the examples, but choose few of the important examples I would like to go through. The first one is example 2.6, that is trying to find the rank of this specific matrix B. So in this matrix, we have 3 rows, but 4 columns, and we would like to determine the rank of this one. So if you observe that closely, row 1 of B is 1, -1, 4, and 2. In row 2, that is 0, 1, 3, and 2. So when we try to find the rank, it means that this specific row cannot be a combination of the other two rows. What do I mean? I mean, if you multiply row 1 with some certain number plus row 2 multiplied by a certain number, and it actually equals to row 3, it means that the rank is only 2 because only 1 and 2, they are independent rows. The third one is actually a combination of the other two rows. Then we say the rank of this specific matrix is 2. But can we find such kind of a combination so that the rank is actually smaller than 3? The biggest number of rank of this matrix is actually 3 because we have 3 rows. But it can be 1, it can be 2, it can be 3, but no more than 3. So can we find something like this? Okay, let's do it. If we have 3 multiplied by row 1, that will lead to 3, -3, 12, and 2. So if we do that and plus 1 multiplied by row 2, we are having 3, -3, 12, and 6 plus 0, 1, 3, 2. That is going to equals to 3, -2, 15, and 8. That equals to row 3, which means this is not full rank, or rank of this matrix. Of B matrix equals to 2. You might raise a question, what happened if it's 1? Well, this case is not possible because the first component of the first row is 1, which is not a multiplier of second row. You cannot multiply anything by the second row to synthesize row 1. And the same, only when you multiply 0 to row 1, you can get 0 component as the first component of like row 2. However, if you do that, second component, third component, and fourth component are also zeros, which means the second row is not possible to be synthesized by row 1. So in that case, the rank of B is actually 2. That is the answer of this example. Okay, before we move on, I would like to change the color back to black. Okay, so we need to solve this problem. We got two equations. That is x1 minus 3x2 plus 2x3 equals to 0. And we have -2x1 plus x2 minus 3x3 equals to 0. So from now on, if you see it's a combination of multiple variables, normally we do not want to solve everything manually. Instead, we would like to use linear algebra or matrix format to solve linear equations. So in this case, what we're trying to do is we are separating these two equations into two parts. The first part is the coefficients, and the second part are the variables. So what I mean is, if we can do something like this, then we can start to calculate for the answer. So this is my variable. In this case, I got x1, x2, and x3. On the matrix, the big matrix over here, we have three components for the first equation. Those are the coefficients of x1, x2, and x3. Over here, we got -2, 1, and -3. So the answer is going to be 0 and 0. How can I do that? Okay, keep in mind we learned about multiplication of matrices in the first part of this module. So the dimension of this matrix, let's call this matrix A. This one, normally we would like to have that as X, and this one is going to be my output. Let's say this is Y. Okay, so the size of this matrix is going to be 2 by 3. This is going to be 3 by 1. 3 rows, 1 column, 2 rows, 3 column. So if we combine them together, the second component of this dimension must be the first component of this dimension. So the answer over here is going to be 2 by 1. Okay, so since this equation over here is valid, so we can start to solve for the answer. Well, we still try to reduce the rank, or try to find out the coefficient on one of the components over here equals to 0. So the first row over here, this one over here is 1. This one is -2. So clearly, if you take row 2 plus 2 multiplied by row 1, we can actually eliminate the first components over here. So let's do it. We have -3 over here. We are going to make this one equals to 0. -5. And this one is going to be 0. Actually, it's plus. So this is something we have. Then we get 1, -3, 2, 0, 1, -5. Okay, so now we got the first component equals to 0, and clearly the second component in the first row can be taken out by this component over here. So I'll do it over here. Row 1 plus 3 multiplied by row 2. That yields. The second one remains the same. Then if you do the operation, you're going to find the first row becomes this one. Okay, so in this part, if you try to solve from 3 components over here, we can actually rewrite the linear equations like x1 plus 7 over 5 x3 equals to 0, x2 minus 1 over 5 x3 equals to 0. So any combination that can fulfill this, those two criterions will be the answer. One of the simplest answer you're going to find is actually x1 equals to x2 equals to x3 equals to 0. This is a trivial one. If you want to find out, if you treat x3 equals to 1, then x1 equals to negative 7 over 5, x2 equals to 1/5. So you can use anything you want to as long as it fulfills this criterion, then you'll be fine. So this is kind of trivial. Therefore, we're going to be more specific to solve some kind of non-homogeneous answer later. But before we move on, I want to talk about inverse. The inverse of matrix is a key that we can try to identify how to find the answer of linear equations. So over here, we got our matrix 2 by 2. 2 by 2 matrix over here, and we try to do it. So there are different ways we can do it. Let's start from the traditional way that I'm going to use I matrix. And the next part is going to be my A matrix. So in this case, what I have is 1, 0, 0, 1. Put a dash line over here. Put the other components over here. So the goal is to make this portion becomes I matrix or identity. Once we can find this, we can convert this part into identity. This part over here is going to be my it's going to be my inverse. So let's start. So clearly, what we're trying to do is to put this one equals to 0. So what I can do is multiply everything by 1/5. 1, negative 1 over 5. In short, I'm divided the first row over here by 5. Second row remains the same. Then, clearly, just like what we did earlier, we take row 2 minus row 1 multiplied by 6. Then this component over here can be removed. When we do that, we're going to have 1 over 5, 0, still 1, still 1 over 5, negative of course. This part remains the same. The second part over here is going to be, let's take care of this part first. Of course, it becomes 0. And once you use this 1 minus 6 multiplied by this row, you're going to get this number equals to 46 divided by 5. Then we carry on the other operation over here. We still have 1 over here. This part over here is going to be negative 6 over 5. Now, we have this one equals to 0. This part I would prefer to get 1 as a component. So to do that, we just multiply everything by 5 over 46. In that case, first row remains the same. Second row becomes, I'm sorry, 5 over 46. This one over here remains a 0. This one becomes 1. So if you multiply everything by 1 over 5 and plus back to the first row, this part becomes identity or I matrix. Then we got 1, 0, 0, 1. And on the other side, this becomes And over here we have 8 over 46, and this one is 1 over 46. Therefore, we got our inverse matrix equals to or it is going to be sorry, that would be my answer. If you don't like this way, there are other formulas certainly we can do. All we can do is, hold on, let me resolve this problem again in a more efficient way. So the first thing we want to do is to find out the determinant. Normally, we are going to define that as A. That is going to be this one multiplied together minus this side. So it's going to be that is going to be 46. Again, I would like to change the color to black. So the formula of a 2 by 2 matrix is actually pretty straightforward. I got A11, A12, A21, A22. That is my A matrix. So my inverse matrix is going to be 1 over determinant A, A22, A11, minus A21, A12, negative A21. So this one is pretty straightforward because we have get this part solved. Then A matrix inverse is going to be 1 over 46, and we're going to swap those two items and make inverse of this column, this and this one. So it's going to be 1 and negative 6. That would be the answer, which is the same as what we did a few minutes ago. Okay, should be pretty straightforward. Now, why do I want to use this one? We got a square matrix on one side, we got a variable. Combine the variables that we can separate or form. We can rewrite the linear equations from equation type of equation format into matrix format. And if we can put the answer on the other side, like the next equation we're going to have, then we can actually use the inverse of matrix to solve for the answer. What I mean is, if I have linear equation like this, what I'm trying to do is to convert that into A matrix multiplied by X matrix equals to Y. That is my output. So if I multiply the inverse on both sides, then this part becomes identity. So it means that my coefficient can be solved by this specific part, which means this part over here can be used to solve for my answer. So let's start. So I got 3 linear equations over here. I put them as metric format. Then I got 2, -1, 3, 1, 9, -2, 4, -8, 11. Over here, my variable are x1, x2, and x3. The answer on the other side is going to be 4, -8, and 15. Okay, so I got my A matrix. I got my x vector. I got my output vector. So if you can find the inverse of A matrix, certainly you should be able to find out what the answer of x1, x2, and x3. So let's do that. A is going to be 2, 1, 4, -1, 9, -8, 3, -2, 11. There are many ways of doing this one. You can use MATLAB. If you have that, you have access of that, you can use your calculator. Since it's 3 by 3, I don't think the calculation is going to be very intensive to your calculator. So you can just use that to find out your answer. If you do that, your A inverse is going to be 1/53. Though the formula in your textbook or any textbook of engineering mathematics should have the answer or formula for this kind of things, you can just apply the formula and find out the answer, or you can use the traditional way, use identity to form the 3 by 6 matrix and convert one side into another identity. Then you can still find the inverse of the matrix. But I would put, oh, I'm sorry, it should be 1/53, and there will be 83 minus 19 minus 44 minus 13, 10, 12 minus 25, 7, 19. So you got this new matrix as your inverse matrix of A. Now, we want to find out x. So it is going to be the inverse matrix multiplied by the output. So if we do that, we got 1/53. Again, use the matrix we just find out. Over here, I got 4, -8, and 15. Okay, so if we multiply everything all together, use regular multiplication techniques, we are going to find out the answer is actually 61/53, -51/53, 13/53, and voila, this is my answer. Okay, so if you do know how to use the inverse of matrix, this technique can actually be a very good tool to solve a lot of linear equations, and this is a technique we're going to use throughout the class this semester. Thank you for watching.